Hi, I'm Mike Mulligan. I'm a nuclear safety advocate. I live a couple miles away from Vermont Yankee. A Pilgrim plant had a reactor trip on. We had a pretty bad blizzard, and it was really bad in the area around the Pilgrim plant. But curious, there was a narrow band, and actually a lot of areas in Boston got 30 inches of snow. Pilgrim, Plymouth, right next to Pilgrim, they only reported 12 inches of snow. So it's curious on why Pilgrim had so much problems. So anyways, they on February 10th, they had at 1400, they had a trip. They had a loss of all off-site power. So they have three, I'm not sure, but 345 kV lines, 3 lines, and they lost them all. So that's kind of suspicious. Why they would lose all 3 lines? It's not suspicious because it was a a hell of a blizzard, but it's suspicious that all 3 of them were lost. So, and then yesterday they recovered power. They recovered the one of the 345 kV lines, and for just a few hours, and then it tripped on them again. It should be noted, nobody talks about it, but loss of all off-site power. When the plant is only up on their diesel generators, it's one of the most riskful events in the industry. It's a loop is a precursor for all the terrible accidents. You have to have a loop first, usually, then it leads to a station blackout and stuff. You get into all one of the things that gets you to a core melt quicker is a stuck open safety relief valve, which they've had a whole slate of problems with brand new safety relief valves. So anyways, a loop is a very serious accident, and it should be prevented at all costs. From the owners to the ISO, they should be responsible to know that if you have a spate of loops and stuff like that, you're going to end up with a core melt. If you have a lot of plants having loops, you're going to have a terrible accident one of these days. And you should always be thinking a loop is a very serious event. And you shouldn't just think of it, oh well, it's just a normal plant trip, and they're on their diesel generators, everybody's safe. That's not the way you should look at it. You should consider this a very serious event, and it needs to be prevented at almost all costs. And certainly our engineering professionalism gets us to the point where we should be above that. So I'm kind of looking around, and they recovered one line, and then they tripped again. So I'm asking myself, well, what's going on with the transmission system? Because that transmission systems are towers 50, 60 feet in the air, and the lines way up in the air. Nobody can touch them, and that type of thing. And they got big old right-of-ways, and all the trees are cut down so that if a tree falls, it never threatens the line and stuff like that. And that's the backbone. Our transmission system is the backbone of our society. If we lose the transmission system in a widespread area, we're in big trouble and stuff. Katrina, as an example, had winds of 120 miles per hour, and it terribly damaged their transmission system. But Energy's transmission system down there in Louisiana was designed for 150 miles per hour. We don't know what our transmission is designed for. All the codes say that should be a minimum of 90 miles per hour, and in the area around Pilgrim, it's a zone that it should be designed for 110 miles an hour and stuff. And so, the question is, well, with the climate change and all that sort of stuff, and Hurricane Sandy and stuff, what is the maximum design of our transmission system as far as wind speed? How many miles per hour can the transmission take? If you had a Category 3 hurricane like Katrina, or 2, or maybe even a 1 and stuff like that, you could do a lot of damage in our transmission system over a wide area. If it hit just in the right manner and it knocked out a few transmission systems and stuff like that, we could be without electricity for many months. Enormous numbers of people without electricity for many months. And stuff, and so, and this 90 mile an hour is the minimum throughout New England as far as the codes are concerned. The area around Pilgrim is in a 110 mile per hour zone. That only talks about the gust. That 110 mile an hour gust for 3 seconds or less than 3 seconds, or for 3 seconds. So that's a gust, and we're talking, Katrina was 120 miles sustained wind speeds and stuff like that. So, how much damage could our New England take if we had a pretty big hurricane, and it destroyed our transmission system in a large way throughout our region and stuff like that. So that's what I'm concerned about and worried about now. So let's look at this guy. This is electric transmission industry development in New England. So this is a study about our transmission system. And this gives you an idea. It's December 27. It's by the New England Energy Alliance, Massachusetts Affordability, Reliability Electric Alliance. And so it goes on. Let's see. Aging hardware, infrastructure condition and capability, aging hardware and reliability effects, overextended lines. As we will detail in section 4, there has been substantial progress in reinforcing New England transmission infrastructure, but the system still consists of hundreds of miles of aging and undersized lines. The majority of the system was constructed during the 1960s and into the early 1970, and its substation wires, towers, and poles are therefore on average more than 40 years old. This aging infrastructure creates many challenges, including procurement of spare parts and obsolescence of older equipment. Hey, right? In the nuke plants, that's what the reverse engineering a lot of components, because there's obsolete parts. The overall condition is not unique in New England. The U.S. has a transmission system from the 1950s and 60s, equipment that is delivering electricity to businesses with 24th century technology. According to the Department of Energy, 70% of the U.S. transmission lines and transformers are 25 years or older, and 60% of the circuit breakers are more than 30 years old. And most transformers are made out of the United States, and baby, you ought to try ordering one of them. How long it's going to take you to get back to get that transformer into the United States? Months. Okay, so there we go on that. And post restructuring transmission infrastructure. They spend a lot of money on upgrading the transmission system, but as for a specific intent. From a broader perspective, much of the capital that has been invested in regional transmission has been dedicated to interconnecting new generation plants that were built in the immediate period after restructuring. 35 generating facilities were constructed between 1999 and 2006, providing more than 11,600 megawatts of new capacity in the region. Prior to reconstruction, no quantity of generating plants have been built and brought to commercial operation over such a short period of time. In this case, increasing the region's electric supply by about 30%. More than $9 billion was spent in construction of new generating facilities during that time. Less than $1 billion was invested in the transmission infrastructure. So they didn't do a broad-scale type of rebuild on the transmission system. They only connected new plants to the system, is basically what they're saying. And you go out in the lines around here and stuff like that, and they've been around for our power lines have been around for a long time, and they're obsolete and old. And the question is, what were they designed for when they, as far as wind speed, when they were first built, and what will be the actual wind speed they can handle now since they're aging system. And remember, all you need is one tower to go down in a line, and it negates the whole line. And if you have a whole slew of towers going down, then like I say, you've gone through the winter with enormous number of people without electricity and businesses in New England if you get hit by the right storm. And that's the question I'm talking about with Pilgrim today. Is why did that 345 kV lines? Why are they having troubles keeping those lines connected to Pilgrim? Are they rebuilding them lines? Has towers been knocked down? Has there been trees that there shouldn't have been by the design considerations? There should be no trees that have knocked over those transmission towers, because they're designed for that. The big right-of-ways and stuff. So what's going on? I'm going to guess they knocked some towers down. There was up to 80-mile-an-hour winds and stuff like that, gust winds, and it's along the coast. I suspect in the area there wasn't too much snow or Pilgrim. As you get closer to Boston and you get south into Connecticut, there's been a lot of snow and wind and stuff like that. So I suspect there was tower damage. What is the extent of it? And so then I said to myself, well, what is the design considerations of our grid system? And so here's another interesting article, and this is about 2007 also, and I believe it's well, I'm not sure. Extreme wind speed regions in New England and New York. So they updated the extreme wind condition for New York and New England is described in this paper. This wind speed data from the National Climatic Data Center, National Institutes of Standards and Technologies, the U.S. National Meteorological Service are analyzing using software from NIST to develop the probable distribution functions. Introduction. The present National Grid U.S. National Grid, is that to talk about National Grid? Is that corporation that's around here running our grid? The present National Grid U.S. transmission wind speed design standards follow the basic wind speed denoted in the National Electric Safety Code (NESC). Wind speed design requirements are most extreme along the seacoast lines and gradually taper off at points more inland. The basic wind speed is 90 miles per hour for a 3-second gust interval. So, and you look down, and they got a map, and Plymouth is deeply in the 110 mile per hour area with a 3-second wind gust. So in other words, the transmission system should be designed for 110 miles an hour. And so the question is that adequate? Is 110 miles adequate? I mean, are the transmission system designed for 110? I don't think they are. I think they're designed for something like 60 miles an hour or 70 miles per hour type of thing. Or they might be designed for higher, but what they're actually now, because they're so old, is 60 to 70 miles per hour and stuff like that. And so the question is, you know, if you have a Category 2 or 3 hurricane and stuff like that, what could, you know, how much damage could be done in New England if it came up and destroyed, you know, got in the right way and destroyed a couple of transmission corridors? Would be in deep trouble and stuff and that type of thing. So this questions whether our electric transmission system in New England is designed for our climate. So, you know, in this paper it talks about, you know, what the minimum speeds are, what is the minimum max design considerations of the grid, of the transmission system. And like I said, it's 90 miles an hour and 110 degrees in the area around the Pilgrim plant are the transmission towers and designed for, you know, what are they designed for? What's the design and stuff? So I mean, that's the basically just that I'm trying to ask the question. Considering how our climate has changed, considering how Millstone this summer, you know, the Long Island Sound was at a higher temperature because of climate conditions. We all know that a lot of water temperatures around Millstone have been climbing for decades. We know the ocean around New England has been warming up and stuff like that. So you know, there's evidence that climate has drastically changed in New England and stuff. And so are we setting ourselves up for a lot bigger hurricane? What is the hurricane that I'm going to research that. What is the hurricane on the one that the speeds? I think it was a Category 3 that went up through the Long Island. There's a mother of all New England hurricanes. It changed our, you know, the flood control of all our streams and rivers and stuff. It was during the Depression era, and we built a bunch of dams on feeder streams and smaller rivers, and we mostly tamed our, you know, the Connecticut River and a lot of our bigger rivers with this effect because of one of the big hurricanes. So this is Mike Mulligan, and again, that question is our transmission system, our electrical transmission system designed? There were inclinations that our transmission system failed with Pilgrim. That Pilgrim doesn't have a reliable supply of off-site electricity and stuff like that for a number of reasons. And so is, you know, is that, how wide of a problem is that in New England? Thank you, Mike Mulligan here.